Hello students, Unit 5 Electromagnetic Waves continuation video. Our next topic, that is Maxwell equations in integral form. We know optics and electromagnetism are the two different branches of physics. From the work of Maxwell, he combined the two units as a single one, that is electrodynamics. Okay, this electrodynamics can be summarized in four basic equations. Okay, that basic equations are called Maxwell equations. Okay, these four equations that can explain behavior of the charges. Okay, then behavior of the current, then properties of electric and magnetic field. Properties of electric and magnetic field. Okay, let we start the first equation, that is Gauss law. Okay, Gauss law in electrostatics. Okay, that is, we know Gauss law relate net electric flux to the net electric charge. Okay, that can be mathematically written as closed interval of E vector dot dA vector is equal to Q enclosed by epsilon naught. Okay, this law states, if suppose I consider a charge, that is positive charge, having the magnitude Q, then it produces electric field lines. Okay, like that. Then I consider a that is Gaussian surface. On that Gaussian surface, large number of electric field lines crosses this surface. Okay, if suppose I add the entire flux for the loop, entire flux for the surface, then that will be equal to Q enclosed. Okay, that will be equal to the charge enclosed by the Gaussian surface. Okay, this law is true for both continuous and discrete charge distribution. Okay, then this law shows this is true for both discrete and continuous charge distribution. Okay, so this law states the electric field line start from positive charge and end with negative charge. Okay, then this law implies that the electric field line does not form continuous closed path. Okay, so mono charge exists. Okay, isolated positive charge or isolated negative charge exists because the electric field lines do not form a closed path. Okay, isolated positive and negative charge exist. Okay, then second equation, that is similar to Gauss law in electrostatics, so we can state this one as Gauss law in magnetism. Okay, this is mathematically written as closed interval of B vector dot dA vector is equal to 0. Okay, this law states the surface interval of B vector over the closed surface is 0. Okay, so this law implies that the magnetic field line of forces form closed path. Magnetic field line forms closed path. That is, if suppose I consider a closed path, okay, I place a magnet near to that. Okay, north pole, it is south pole. So from north pole magnetic field line start. Okay, it enter this region, then it will leave the region. Okay, the adding these two values we get 0. So the magnetic field for the closed loop will be 0. Okay, this statement refers monopole does not exist. There will be not any separate south pole or north pole. Monopole does not exist. does not exist. For gas line electrostatics, monopole, that is monocharge exists. Isolated positive charge and negative charge will exist. Okay, it form discrete or continuous charge distribution. Okay, here it form a closed path. Okay, then third equation, that is Faraday law of electromagnetic induction. Faraday's law of electromagnetic induction. Okay, we know this law relates electric field with the changing magnetic field. Okay, this is mathematically represented as E vector dot dl vector is equal to minus d phi b by dt. Okay, this is from the expression, that is Em of psi is equal to minus d phi b by dt. Okay, then the fourth equation, that is modified ampere sector law. Okay, this law that relates the magnetic field around the closed path to conduction current and displacement current. Okay, this is mathematically written as closed law of B vector dot dl vector is equal to mu naught I enclosed. Okay, this is ampere sector law. Then Maxwell introduced the term, that is mu naught IC plus ID. The enclosed current is a summation of conduction current and displacement current. Okay, then next the equation became B vector dot dl vector is equal to mu naught IC plus mu naught ID. Okay, we know ID is a displacement current, that current produced in between the capacitor plate. Okay, by changing the electric field, that is epsilon naught d phi e by dt. So the modified ampere sector law, that is closed law of B vector dot dl vector is equal to mu naught IC plus mu naught epsilon naught d phi e by dt. Okay, these are the four equations of Maxwell. Okay, by using this equation we can ensure the existence of electromagnetic wave. Okay, see first equation, that is called Gauss law in electrostatics. Okay, that is closed law of E vector dot dA vector is equal to Q enclosed by epsilon naught. Okay, then second equation, that is Gauss law in magnetism. Okay, closed law of B vector dot dA vector is equal to 0. Then third equation, that is Faraday law of electromagnetic induction, that is closed law of E vector dot dl vector is equal to minus d phi b by dt. Then the fourth equation, that is modified ampere sector law, closed law of B vector dot dl vector is equal to mu naught IC plus mu naught epsilon naught d by dt. Then this phi can be written as integral of E vector dot dA vector. Okay, this is our today's assignment. I gave 5 short answer question. Okay, from this you have to write first 4. This is the next part, let me discuss by tomorrow. You have to notice the page number also. Okay, then long answer, that is also 5. This one is a question that we discussed few minutes ago. Okay, then that is its experiment, we will discuss by tomorrow. Then this one we already discussed. Then this one, importance of Maxwell correction, this is also today's class. Then write down the properties, this will be discussed by tomorrow. Okay, so you have to write 4 short answer question and 3 long answer questions. Okay, refer your book, page number is indicated here. Let me see a short recap of today's class. This is first one, that is importance of Maxwell correction. Okay, by using the correction term, Maxwell correction term, we can found the existence of electromagnetic wave in free space. Okay, that is a major thing of this part. Then next one, that is integral equation. Okay, Maxwell integral equations. We know in first equation, that is closed rule of E vector dot dA vector is equal to Q enclosed by epsilon naught. Okay, this equation states or it relates electric flux and net charge. This is nothing but the electric flux. Okay, this is true for both continuous and discrete charge distribution. Okay, from this equation we can consider electric field start from positive charge and terminate with the negative charge. Okay, then this implies that the electric field line do not form closed path, so isolated point charge exists. Okay, then second one, that is from that is a Gauss law in magnetism. This equation states the magnetic line of force form a continuous closed path. Okay, so monopole does not exist. And the third one, that is Faraday law of electromagnetic induction. This law relates the electric field with the changing magnetic field. Then fourth one, that is modified Ampere sector law. Okay, by using these four equations we can ensure the existence of electromagnetic wave. Okay, thank you. Complete the assignment by tomorrow. Okay, thank you.